This video is for section 8.2. It's on parallelograms. We're going to look at 4 theorems about parallelograms. This is theorem 8.2. So this is the second theorem in chapter 8. It tells you that the opposite angles of a parallelogram are congruent. It's a very simple theorem. Here's a shape. We know it's a parallelogram because of these marks, not because it looks like it. So when we have a shape with those marks, here's what we know. The opposite angles are congruent. So those two angles are opposite, they're congruent to each other. These two angles, they're opposite as well, so they're congruent. But these don't have to be congruent. For these, we could figure out these angles because these lines are parallel. So we know that those angles add up to 180. These match, they're the same. These match, they're the same. These ones don't, but they add up to 180. So here's an example. Here's a shape. You got to identify the shape first. Because of the marks, we know that the opposite sides are parallel. So this is a parallelogram. This angle is 100, so this angle is 100. We can figure out this angle because we know these two angles add up to 180. So if that's 100, that's 80 degrees. Remember, opposite angles are congruent in a parallelogram, so that one's 80 degrees. Very, very simple. The opposite angles of a parallelogram are congruent. The adjacent angles end up being supplementary. This is theorem 8.3. It tells you that the opposite sides of a parallelogram are congruent. So here's a shape that looks like a parallelogram. We know that it is a parallelogram because of the marks. If the opposite sides are congruent, you use slash marks to indicate that. So here's an example. This is a parallelogram because of the marks. If this right side is 6 inches, the left side is 6 inches. If the bottom is 5 inches, the top is 5 inches. Now, these are side lengths. There's no relationship with the length of the adjacent side lengths. So don't think that there is, like we did on the last one, where the adjacent angles added up to 180. There's nothing like that here. So you would need to know the length of both of these sides to figure out both of these. Theorem 8.5. It tells you the diagonals of a parallelogram bisect each other. This shape is a parallelogram. These are the diagonals. Remember, bisect means split in half. So if these diagonals split each other in half, that means those two pieces are the same. And these two pieces might be different lengths than those, but they match each other. That's what bisect means. They split each other in half, and that's how you show it with the marks. Don't just say they bisect each other because it looks like it. You need the marks. Here's an example. This is a parallelogram because of these marks. So we know that this piece and this piece match. So if this is 4 inches, we know that piece is 4 inches. And we're talking about a length here. This is not an angle measure. Notice the unit. It's in inches, not degrees. This diagonal also gets bisected. So if that's 5 inches, this piece over here is 5 inches. Last one. This is theorem 8.6. It tells you that the diagonal of a parallelogram separates it into 2 congruent triangles. So here's a parallelogram. Notice the marks. You end up with 2 triangles. Well, we just talked about a theorem that said if you have a parallelogram, then the opposite sides are congruent. Notice how this segment is on both triangles. You can show that these 2 triangles are congruent by side, side, side. So if you know the triangles are congruent, then you know their corresponding parts are congruent. So those angles are going to be the same. These are opposite angles, so we know they're congruent. And these are alternate interior angles, if you remember that term. They're going to be congruent. So this one theorem tells us these 6 pairs of parts that match because you have 2 congruent triangles. So here's an example. This is a parallelogram. If this left side is 8 inches, we know the right side's 8 inches. Very simple. The bottom's 10 inches, so the top's 10 inches. This angle's 65 degrees. This one's 65 degrees. This angle's 55 degrees. Its alternate interior is 55 degrees. Now, you can find this angle measure as well as this angle measure too. Remember, every triangle has 180 degrees. So if this is 65 and that's 55, that's 120 degrees. That means you're left over with 60 degrees.